Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, sketch the function. So we are given this function f of x equals 2x to the power 4 minus 4x squared plus 2. So this is a polynomial function. Now the first step for sketching the function is to analyze the discontinuities in the function. Now since this is a polynomial function, it won't have any holes or vertical asymptote. So there's no hole or vertical asymptote. And since it's a polynomial function, it won't have any horizontal asymptote or oblique asymptote as well. There won't be any horizontal and oblique asymptotes. So now the next thing we can do is to find the intercepts for this function. So we can start by finding its x-intercept, and for x-intercept we'll have to sub in the function value as 0. So we get 0 equals 2x exponent 4 minus 4x squared plus 2. Now this is a quadratic equation in x squared. So we have to solve this equation. So the first step is to factor out a 2. So we can do common factoring. So now this is a simple trinomial. So we can use the sum and product method. We have to find two numbers whose sum is -2 and product is equal to 1. So the numbers are -1 and -1. So now we can factor this quadratic function. So we can rewrite this as x squared minus 1 times x squared minus 1. So now we get the same factors. So we can set any one of them equal to 0 and solve for x to find the solutions for this equation. So we can isolate x by adding 1 to both sides. So the ones on the left side will get cancelled out. So we get x squared equals 1. And now we can apply square root to both sides. So we get x equals plus minus 1. So that means this function has two x-intercepts, 1, 0 and -1, 0. Now we can find the y-intercept. So for y-intercept, we can sub in x as 0. So f at 0 equals 2 times 0 exponent 4 minus 4 times 0 square plus 2. So f at 0 is equal to just 2. So the y-intercept is 0, 2. Now we should find the critical points for this function. And for that, we'll have to find the derivative of the function. So prime of f at x equals, so we'll have to use the power rule. So for the first term, so 2 is the coefficient, so it will stay as it is. And the derivative of x exponent 4 as per power rule will be 4 and then x 4 minus 1. So as per the power rule, we move the exponent to the front and then we subtract 1 from the exponent. Now in the second term, 4 is the coefficient, so it will stay as it is. And for x squared, we'll move the 2 to the front and subtract 1 from 2. Now the number term 2 is a constant, so its derivative is equal to 0. Now we can simplify this expression. So prime of f of x equals, so in the first term we can do 2 times 4, which is 8x cubed, minus 4 times 2 is 8, and 8x. Now critical points are points at which the derivative of a function is either equal to 0 or undefined. So on the left side, we set the derivative equal to 0 and solve for x. Now since the prime of f at x is a polynomial function, there are no x values that will make the derivative undefined. So we only have to solve for cases where the derivative is equal to 0. So now we have to solve this equation. So we can common factor 8x on the right side. So we get x squared minus 1. So now we get two cases. So as per the first case, 8x equals 0. And then as per the second case, x squared minus 1 equals 0. So now we can solve for x. So we can divide both sides by 8. So the 8's on the left side get cancelled out. So we get x equals 0. So this is our first critical number. So now for the other case, we add 1 to both sides. So we get x squared equals 1. And now we can apply square root to both sides. So on the left side, the square root and the square cancel each other out. So we get x equals plus minus 1. So that means there are 3 critical numbers in total. Now plus and minus 1 are also the x-intercepts. That means those x-intercepts are the critical numbers. Now the next step is to find the critical points. So for that we'll have to sub in these x values one by one in the given function to find the corresponding function value. So we can start with -1. So f at -1 will be equal to 2 times -1 exponent 4 minus 4 -1 square and plus 2. Now we have to simplify this expression. So -1 exponent 4 is just 1. So we just get 2 times 1, which is 2. -1 square is positive 1. So -4 times 1 is -4. And then plus 2, which is equal to 0. So the first critical point is -1, 0. Now we can sub in the other x value. So x equals 0. So we get 2, 0 exponent 4, 0 square plus 2. So the first two terms become 0. So we get f0 equals 2. So the second critical point is 0, 2, which is also the y-intercept. Now for the third critical point, 1. Sorry. So we have to sub in x as 1. So 1 exponent 4 is equal to 1 and 2 times 1 is 2. 1 square is 1 and then -4 times 1 is -4. 2. So f at 1. So the third critical point is 1, 0. So these are the three critical points in this function. And now we'll use the first derivative test to find whether these critical points represent local maximum, local minimum, or neither. So for that we can use the number line method. So the first step is to draw the number line and show the critical numbers on it, which are -1, 0, and then 1. So these three critical numbers divide the number line into 4 parts. So we'll have to use a test value from each part and then sub in that test value in the expression for prime of f at x to find whether the derivative is greater than 0 or less than 0 in that part of the number line or that interval. So if the derivative is greater than 0, that means the function is increasing, and if the derivative is less than 0, that means the function is decreasing. So to the left side of -1, we can use the test value -2. Between -1 and 0, we can use the test value -0.5. Between 0 and 1, we can use the test value 0.5. And to the right side of 1, we can use the test value 2. So let's start with the left side, -2. So we'll use this expression for prime of f at x. So we'll start with prime of f at -2 equals 8 times -2 cubed minus 8 times -2. So -2 cube is equal to -8, and 8 times -8 is -64 plus 16, which is equal to -48. So that means the prime of f is negative on the left side of -1. Now we can use the other test value. So prime of f at -0.5 is equal to 8 times -0.5 cubed minus 8 times -0.5. So -0.5 cube is -1 over 8, and 8 times -1 over 8 is -1, and then -8 times -0.5 will be +4, which is equal to +3. That means the prime of f is positive on the right side of -1 and less than 0. Now we can use the third test value, prime of f at 0.5. So we get 8 times 0.5 cubed minus 8 times 0.5. So positive 0.5 cube is equal to 1 over 8, and 8 times 1 over 8 is 1, minus the -8 times 0.5 is -4. So we get -3. So that means the function is decreasing between 0 and 1 because prime of f is less than 0. And now we can use the fourth test value. So f at 2 equals 8 times 2 cubed minus 8 times 2. Now 2 cubed is equal to 8. So 8 times 8 is 64 minus 16, which is equal to 48. So that means the prime of f is greater than 0 on the right side of 1. That means the function is increasing in that interval. Now we can use these results to find the local max and local minimum. So there is a local minimum at -1, 0, because to the left side of -1 the function is decreasing, and to its right side the function is increasing. Now we can analyze the second critical point. So at the second critical point there is a local maximum. So local maximum at 0, 2, because the function is increasing on the left side of 0 and it's decreasing on its right side. And then there is local minimum at 1, 0, because the function is decreasing on its left side and increasing on its right side. So these are the steps for analyzing this type of function, and now we can use all of this information to sketch this function. So as we observed, there are no holes, vertical asymptotes, no horizontal and oblique asymptotes. So we can start by plotting the intercepts. So the x-intercepts are 1 and -1. So let's assume the x1 is here and then -1 is here. And then the y-intercept is 2. So let's assume it's here. Now we figured out that there is a local minimum at -1, 0. So that means, so to the left side of -1, the function is decreasing. So the function should be sloping downwards from left to right towards -1. And to the right side of -1, the function should be sloping upwards. Now at local maximum, so to the left side of the local maximum, the function should be increasing. So from left to right, the function should be sloping upwards. And to the right side of local maximum, the function should be decreasing. So the function should be sloping downward from left to right. Now at the next local minimum, so the function should be decreasing from left to right on the left side of 1. So it should be like this. And on the right side of 1, the function should be increasing from left to right. So it should be sloping upwards. And now we can join these parts. So on the left side, go like this, then like this, then like this, and then it will continue like this. So this should be the sketch of this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.